I briefly talked about these division problems with you yesterday. Again, my goal is not to get you to divide. My goal is to get you to recognize restrictions. So, what 3 parents do you need to be concerned about having restrictions right now? Square root, which really means any even root. So, 2, 4, 6, 8. Any even root. 0, or rational, which means there's an x on the bottom, and log. All right? So, when there's an x on the bottom, we have to worry about it being a 0. When there's a square root, we have to worry about it being greater than or equal to 0. So, in this particular problem, we have an x on the bottom. So, what would make our bottom 0? 0. So, we know x cannot equal 0. In addition, the top, it's not the fact that there's an x up there, it's the fact that there's a square root up there, okay? So remember, our square root has to be greater than or equal to 0, which means x has to be greater than or equal to -3. So to satisfy both of these, to be bigger than -3 and not equal to 0, then we will go from -3 to 0, and then start back at 0 and go to positive infinity. Okay? When I look at g over f, I have 2 problems. Not only is there an x on the bottom, there is also a square root on the bottom. So, not only can the bottom not equal to 0, it has to be bigger than 0. So where I could put equal to there, I cannot put equal to here because the bottom cannot equal 0 and the square root has to be greater than 0. So when is x plus 3 greater than 0? As long as x is bigger than -3. Does the x on problem present a problem as long as it's not under a square root or attached to a log? Does the x on top present a problem? No. So I don't have to worry about the top this time. So I've just got to be bigger than -3, which would be -3 to infinity. Okay? When I get to 7, do I need to worry about this x squared on top? No. Do I need to worry about the square root on the bottom? And is this one of those that we talked about? One that if you will just, we talked briefly yesterday, if you will just get these straight in your head. So let me review that really quickly again so that we don't have to keep having the same conversation per problem, all right? So remember, if I have x squared minus 49, it's going to look like that. What's my magic number? 7. So my domain is going to go from negative infinity to 7 and 7 to positive infinity. But if I change it around, 49 minus x squared, the magic number is still 7, but it's going to start at 7, touch 7, and come back down to, so it's going to start at -7, touch 7, and come back down to -7. So what would my domain be here? -7 to 7. What would my range be on this picture? 0 to infinity. What is my range going to be on this one? 0 to 7. All right? So, the sooner you're able to just spit that out, the easier it will be, and you won't have to keep mentally thinking about these each time you see them. Okay? So, x on top, x squared doesn't have a restriction. I don't need to worry about that. On the bottom, I have the square root. Because it's on the bottom, it can't be greater than or equal to 0. It has to be greater than 0. So, is this the half circle or the arrows that go out? The half circle. So, does that mean it's got to go from -1 to 1? Without the bracket because it has to be bigger than 0. So, with that, then I just have to do -1 to 1. Here, we have 2 problems. We have a square root on the top, and we have a x on the bottom. So this means x cannot equal 0. If I take the square root away, do I need to worry about the top? If I just have 1 minus x squared, do I need to worry about the top? No. A parabola doesn't have a restriction, but does a square root have a restriction? All right? Now, because it's on top, can it actually equal the 0 this time? So that's why you have the negative 1 and the 1, and we've got to omit the 0 in the middle. So no 0 on the bottom, and this would go from negative 1 to 1 without being able to equal to 0. Okay? All right. Then on 12, you went to compositions of functions. You were told to do f of g of 3, and then g of f of negative 2. So in order to do f of g of 3, I first do what? G of 3. And then whatever g of 3 becomes, is that what goes into f? Okay? So I did g of 3. 2 times 3 minus 3 is 3. So to do f of g of 3, since that equals 3, what do I put in place of g of 3? 3. So f of 3, 3 squared minus 1 would be 8. To do g of f of negative 2, what do I do first? F of negative 2. So f of negative 2 squared would be 4, minus 1 would be 3. So now in place of f of negative 2, what can I put? In place of f of negative 2, what can I put? 3. So g of 3 would then come back to 2 times 3 minus 3 would be a 3. All right, same thing on 13. You were told to do f of g of 3. So g of 3 is going to give me, g of 3 is going to give me 2. So then I find f of 2 because g of 3 is equivalent to a 2, which gives me an 8. And here to do g of f of negative 2, I do f of negative 2 first. Now that I know f of negative 2 is 8, then I'm really finding g of 8, and the square root of 9 then would be 3. Okay. Then you were told to find f of g of x, g of f of x, and the domain of those. So here's f of x, here's g of x. F of x by itself is a line. What is the domain of the line? Our real numbers. G of x by itself is a line. What is the domain of a line? Our real numbers. So now we're going to do f of g of x, which means take this and put it in place of x. Now I get down to 3x minus 1. What is 3x minus 1? A line. What is the domain of a line? Our real numbers. Because I did f of g of x, the domain will be g of x and what I got. So since the domain of g of x is all real numbers and the domain of this is all real numbers, what's my final domain? All real numbers. And then to do g of f of x, I'm going to take this and put it in place of x. And again, I'm going to end up with a line. I've got to look at f of x and my final answer. Line and line means I have all real numbers. Okay? When I get to 16, it gets a little bit more complicated because I have a quadratic, which has a domain of what? Our real numbers. And I have a rational function, and in this case, the domain cannot equal what? 1. The domain cannot equal 1. All right. So when I do f of g of x, I take this and I put it in place of x, which means I square it. 1 times 1 is 1. I just write that as squared. So now, based on this, what can x not equal? 1. I have to take that paired with g of x because that was my input. I have to take that paired with g of x. Well, it's still not real complicated. X can't equal 1, x can't equal 1, so what can x not equal? 1. So negative infinity to 1, 1 to infinity. Here, I'm going to take this and put it in place of that. So I'm going to have x squared minus 1, which actually becomes x squared minus 2. So if that is x squared and that is 2, does it make sense to you that x cannot equal plus or minus the square root of 2? That paired with f of x, what was the restriction on f of x? Nothing. So that paired with all real numbers, then it's just plus or minus the square root of 2. So negative infinity to negative square root of 2. Negative square root of 2 to positive square root of 2, and then positive square root of 2 to infinity. Positive square root of 2 to infinity. 17. Parabola, all real numbers, right? Square root has to be greater than or equal to 0, so x has to be greater than or equal to negative 1. F of g of x says take this, put it there. So when I square a square root, the square root goes away, and when I simplify, I'm left with x minus 1. What am I graphing when I graph x minus 1? A line. What is the restriction on a line? There's not one. But I have to go back, and I've got to take this no restriction with this restriction, and who becomes my final answer? The restriction. And so it's still, because of g of x, I still have to be bigger than negative 1, so negative 1 to infinity. And then when I go the other way around, this goes in place of that, so I'm going to have x squared minus 2, and so that becomes x squared minus 1. So is this what we talked about just a moment ago? Is this my square root with the x squared minus 1 underneath it? Is this my x squared with the square under the square root, either this or the half of the circle? Is that what we talked about at the beginning of the class period? Which is it, the one that goes out or the half of the circle? The one that goes out. So what's the magic number? 1. So negative infinity to negative 1, 1 to infinity. Paired with f of x, which has no restriction, so does this become my only restriction? Okay, so I have a question. If somewhere along the way it said that x cannot equal 3, then would I go from here to here, from here to 3, and then from 3 to infinity? Would I have to incorporate that 3 in this restriction as well, that x cannot equal 3? Okay? All right, 19. Domain, all real numbers. Okay, is this the goes out or upside down circle, or top half of a circle? I'm sorry. Top half of a circle, so from negative 1 to 1. Negative 1 to 1. When this goes there, it just makes it go away, so what am I left with? What is it? Negative x squared plus 1. What am I graphing? Parabola. What's the domain of a parabola? All real numbers. Paired with that restriction, all real numbers versus that, then the negative 1 to 1 becomes your final answer. Okay? Here, when I do it the other way around, and I put x there, well, what is x squared? I'm sorry, when I put x squared there, what is x squared squared? X to the 4th. Well, is 1 minus x to the 4th going to work the same way as 1 minus x squared? Yes, it will. 1 minus x squared. And what's the magic number still? What times what times what times what? 1. All right? And this is that upside down circle. Or I keep saying that. It's not an upside down circle. It's the top half of a circle. And so negative 1 to 1. All reals, ultimately negative 1 to 1. So y'all remember x to the 4th and x to the 6th work the same way as x squareds. Okay? And then on 21, it gets a little bit more complicated. X can't equal 0, x can't equal 0. Agreed? All right? So now when I take this and put it in place of x, I create a fraction and a fraction. So what do we do when you have a fraction and a fraction? You multiply by the reciprocal. So 1 over 3x over 2 becomes 3x over 2. What does 3x over 2 graph? Think about it. It's real simple. What does 3x over 2 graph? A line, right? So line has no restriction. That has not equal to 0. So with that and that, it becomes not equal to 0. So negative infinity to 0, 0 to infinity. Why am I going back to g? Because I did f of g. It's the one you are inputting. So you got to look at the one you're inputting along with your final answer. And this one, you're just going to do the opposite. So you're going to put 1 over 2x. So when you have 3 over 2x, then you become 2x over 3 because you're multiplying by that reciprocal. So again, that's a line. Paired with that, again, we cannot equal 0. All right, and then I believe the next part is where you're writing two functions. And do not make this complicated and do not stress a lot over this. Remember, h of x is defined as f of g of x. So do I have to put g into f? Okay? So if I let f be just the parent square root, and I let g be that, when I do f of g of x, does that take that and put it under the square root? That's the easiest way. You don't have to make these complicated functions. So I have the square root. I let that parent, square root of x, be one function, and then I make that the other function. So to put that under the square root, I have to let f of x be the parent so that when I do f of g of x, then that goes under the square root. Well, instead of square root, what do I have here? Absolute value. So let f be the parent absolute value. And what do I need to plug into the absolute value? 3x minus 2. So if I let f be the absolute value, g be that, then that puts 3x minus 2 into the absolute value. What parent am I looking at here? X to the what? Fifth. So if I let f be x to the fifth plus 2, then if I put that in there, does it become x minus 3 to the fifth? Okay? And again, I wouldn't stress a lot over these. It's really simple. It's just recognizing a quick parent. And then whatever's under that parent becomes your g. So because the x minus 3 is in the parentheses, that's what my g becomes. And f just gets written as a plain old x. Okay? So please remember, if I do q of x equals r of s of x, would I need to look at q of x and would I need to look at s of x in order to get my final domain? Do I need to know the restriction on s and the restriction on q for my final answer? But if I do s of r of x, who do I need to look at? Q and r. It's the input and what you end up with. Okay? All right.